We're back. We're still on Chapter 11, Introduction to Hypothesis Testing, Part 1. Just to shake things up a bit and for a little change of theme, I'll decorate the slides in this lesson with images from Sherlock Holmes to reinforce the idea that we are now on a journey of clues, hypotheses, deduction, detective work, and discovery. Remember Watson's proclamation, a brilliant deduction, Holmes. By the end of Chapter 11, you too will have all the tools you need to make your own brilliant deductions. Putting things in context, we just finished covering Unit 1, the logic. Now we're on Unit 2, hypothesis types. Then we'll move on to Unit 3, we'll look at some examples. Then in Unit 4, we'll look at the level of significance. Unit 5 is critical values and critical regions. Unit 6 is directional tests. Unit 7 is more examples. And Unit 8 is errors of influence. Right now we're on Unit 2, hypothesis types. A scientific hypothesis is a statement of expected outcome. It's also called a research hypothesis. A statistical hypothesis is a testable hypothesis, also called the null hypothesis. In text form, let's hypothesize that students at International University are smarter than average. Or we could hypothesize that the control condition is less effective than the experimental treatment if we were going to, for example, do a test of a new program designed to increase students' levels of well-being, and we could have a control group and an experimental group. And the hypothesis might be the control condition is less effective than the experimental treatment. We could have a hypothesis men and women exhibit different degrees of variability in depression. So note here, we're not looking at different mean levels, we're looking at variability. So there's more maybe variation among men or women. And then we have a hypothesis there's no relationship between IQ and math anxiety. In symbolic form, you can see how each symbolic statement matches the following verbal statements, going from top to bottom. Students at International University are smarter than average. So you can see that the mean of the population, IQ, is greater than 100. The control condition is less effective than the experimental treatment, so the mean of the control is less than the mean of the experiment. Men and women exhibit different degrees of variability in depression, so the variance for males is not equal to the variance for females. There is no relationship between IQ and math anxiety, so that symbol rho sub xy is the correlation between x and y, and it equals 0. If these symbolic statements are not clear to you, stop the video for a minute and take some time to understand how the mathematical statements match the verbal statements. Each statement is about the value or the relative value of one or more population parameters. Some statements include inequality signs. Some statements include not equal signs. Some statements include equal signs. And in text form, students at International University are of average intelligence. the control treatment is as effective as the experimental treatment. It's a little different than the hypothesis we saw before because now we're looking at the null hypotheses for each study. Men and women exhibit the same degree of variability in depression, and there is no relationship between IQ and math anxiety. So we'll denote the null hypothesis with the following symbol, capital H sub 0. And the null hypothesis in symbolic form is, for the first study, it was the mean of IQ equals 100. The second study is the mean of the control group equals the mean of the experimental group. The third one was the variance for males equals the variance for females. And the last one was the correlation between X and Y equals 0. Each is a statement about the value or the relative value of one or more population parameters. All statements involve equal signs. The null hypothesis may not be what your theory suggests, but by virtue of the equal sign, it is statistically testable. The research hypothesis and the null hypothesis can be the same. The researcher believes that in the population there is no relationship between IQ and math anxiety. The researcher believes that in the population there is no difference on average between the experimental treatment and the control treatment. The only requirement for a hypothesis to be testable is that it can be written as one or more equations with population parameters on the left and constants on the right. So here we have a null hypothesis is that the mean IQ equals 117. A null hypothesis could be the mean of the experimental group minus the mean of the control group equals 8.75. Another null hypothesis could be the correlation between X and Y equals 0.63. So this was another short unit. We've just completed Unit 2, Hypothesis Types, and now we'll move on to some examples. And then we'll look at levels of significance, critical values, critical regions, directional tests, some more examples, and then errors of inference.